everyone, this video is about the derivation of suvat formulas. So here are 5 suvat formulas without S, U, V, A, T, and remember S displacement, initial velocity, final velocity, and so on. We can derive using algebra and basic definitions. So acceleration by definition is the change in the velocity, final minus initial divided by the change in time or just time. And average means you add divide by 2, and the velocity is displacement divided by time. So we use these 3 basic definitions to derive the other formulas. So from definition of acceleration, we can just rearrange and we get v equals u plus at, first formula. And for here we have the average velocity. We can just substitute. We get u plus v all over 2 equals s over t, and if you just multiply both sides by t, we get the second formula, 1/2 u plus v all times t. And now if we want to use this formula, so now from this formula we just replace the v with u plus at. We have 2u plus at. We distribute, we get ut plus 1/2 at squared. And this is the non-MF19 formula. So from this formula we can just move the at to the right, v minus at. So now we can replace this u with v minus at. So we have 2v minus at. After multiplying, expanding, we get vt minus 1/2 at squared. And now we know that the average velocity is u plus v all over 2, and it's basically from here, but we replace the t with v minus u all over a. So from here, t is v minus u divided by a. So we replace the t with v minus u all over a. So this means we have s divided by v minus u over a, which means it's s times a over v minus u, and a times s is as, and we can cross multiply. We have the difference of 2 squares, v squared minus u squared equals 2as, or v squared equals u squared plus 2as using calculus. So remember, if we are using suvat, the acceleration must be constant. So the a is a constant, and the initial velocity is called u, and the initial displacement is 0. So from here, v is the integral of a. Since a is a constant, we get simply at plus the constant of integration. Initially, when the time is 0, the velocity is u. So this means 0 times a is 0, so the c is u. So this means the v equals u plus at. So from here we just replace the c with u. We get u plus at. And s is the integral of the velocity. So the integral of this, the integral of u plus at is ut plus 1/2 at squared plus c. But when the time is 0, the x is 0. So this means the x or the s, this is actually just like s here. So the displacement is just ut plus 1/2 at squared. Using graphs, so here we have constant acceleration, initial velocity, final velocity. If you want to find the gradient is the acceleration, which is v minus u divided by t. And if you find the area under the graph, so this area is u times t, this area is base times height divided by 2, the base is t, the height is v minus u, which is at. Alright, so we have 1/2 at squared for the area of the triangle plus ut. Alright, that's it. I'll see you again next time.